So welcome, first of all, welcome. So this is a small introduction just supposed to be given by our chair, Alex, but he has other things to do today, so I'm substituting for him. Before we go forward, maybe we can quickly go and introduce ourselves. I'm Sharad Mehrotra. I'm a professor in computer science, and my area is data management, security, and so on. Maybe let's just do the UCI faculty, and then we can go down to students.
I'm Ellie Bozorgzadeh. I'm a faculty in computer science department, and my research is in embedded systems.
I'm back here. I'll be talking to you a little bit later. I'm Nalini Venkatasubramanian. I'm a professor of computer science. Been here for nearly 18 years. So, you'll hear about some of the projects we've done in the last few years.
Maybe we can start with you.
Hi everyone, my name is Samaya. I did my master's in computer science, majoring in computer security related subjects, and I'm currently a researcher in the security lab at Georgetown University.
Excellent.
Hello everyone, my name is Amari Lewis. I am a computer science major at Winston-Salem State University in North Carolina, and I am a math and French minor.
Excellent.
Hi everyone, I'm Renata Otavi. I'm doing my master at University of California, San Diego with the database lab.
My turn. I'm George. I'm a master student in UC Davis. My main background is in FPGA-based accelerators and embedded systems.
Excellent.
Hi, I'm Matthew. I'm an undergrad from UC Berkeley, and I'm interested in programming.
Very good.
Hi, I'm Hugh. I'm also at UC Berkeley, and I'm interested in artificial intelligence and statistical methods there.
Hi, I'm Jordan. I'm an undergraduate at the University of Kentucky in computer science and math, and I'm interested in algorithms and theory.
Excellent.
I'm Farah Zaripur.
I didn't get you. Sorry, is it again?
I'm Farah Zaripur. My degree was in physics from Whittier College, and I'm interested in computer and programming languages as well.
Excellent. So you're a reformed physicist?
Yes.
Hi, my name's Kalechi, and I go to NC A&T, and my major is computer science. My minor is applied math, and I like to do research in machine learning.
Excellent.
My name is Joshua Pritchett, computer science major at the University of Alabama, and my interest is machine learning.
My name is Dan. My major is computer science too, and I'm interested in machine learning and AI.
Excellent.
Yeah.
We have a lot of machine learning going on.
I'm Paul Griff. I'm a master's student at CSUN, and I'm doing research in net neutrality violations.
Hi everyone, I'm Cody Kinnear. I'm an undergraduate student at Allegheny College, it's around Pittsburgh, Pennsylvania, and I'm interested in software engineering.
Excellent.
My name is Max Wolotsky. I'm an undergraduate student at Cal Poly Pomona, and my research is in security.
Hi, my name is Ray. I'm actually an undergraduate student here at UCI, and I'm interested in artificial intelligence and natural language processing.
Excellent. Excellent. So, all right. So before my task today is to spend 10 minutes and give you a little bit of highlight of the computer science department, which is what I will do. But before I go further, let me quickly not only welcome you guys, but also let you know it's reasonable for today is one of the most important days in the perspective of deciding where you spend the next 4 or 5 years or whatever it is. So make the best use of it that you can. Identify and meet the faculty who you think you're the most of interest in. Most faculty are very interested in meeting you, so they'll try to make time and so on to give you a little bit of time so that you can chat with them directly and so on. Do you all have a sort of a plan from 1 to 3? Which is there anybody who doesn't still have a plan? Or if you have a desire to meet more faculty, if anybody has that, let Ellie know sometime, and then she will try to make arrangements behind the scene. Second thing is, I think it's wonderful that most of you have a sort of an interest coming into the particular area you want to work in. One thing that UCI practices, and we kind of make sure that we do that, is interests evolve, and it's perfectly fine for your interest to evolve. If you join us, and today you want to work in machine learning, tomorrow you say, hey, I want to work in big data. That's fine, no problem at all. So shifting between advisors, shifting between things is a perfectly normal thing. The expectation, in fact, for us is that about less than a third of you will do what you intended to, what you stated you want to do. We are not looking at you from, hey, this guy is the best machine learner that we can kind of get. We are looking at you as a student, complete overall student, and saying, hey, this is a really good student who's got all the right material, let's get him or her here. Okay? So shifting is perfectly normal. All right. So let me give you a 2 cents worth on computer science department. UCI is a very vibrant school. okay? The Department of Computer Science. We are one of those schools which is frequently underrated, but we are very, very good. And you'll hopefully get a sense of that as we go through the presentation. So let me start by telling you, and I'm actually finding out myself too, the slides were sent to me yesterday. All right, we are founded in 1968, and when we started off, I guess we were a single department underneath the whole university. So usually a department has a college to which it belongs, or a school to which it belongs, and so on. We were basically a orphan department by ourselves, okay? Somebody started the computer science department. And then finally, they had to figure out what to do with us. So they created a School of Information Computer Science. In the School of, and this is actually a very unique opportunity. This is one of the things which makes us really truly unique. So we have a School of Computer Science in which we have a Computer Science department, which is the larger chunk of it. There's also a Department of Informatics, and there's also a Department of Statistics. And if you think about it, all the guys who talked about machine learning, and all the guys who talk about data management, and all the guys who talk about security, a lot of these things actually are interdisciplinary. Statistics is extremely important. So having statisticians right next to you to consult and to talk to and do research with is a very, very huge thing. The same is true for informatics, because the minute you go into, let's say, security or privacy research, all of these things are cross-cutting. Humans get involved. Security and privacy doesn't make any sense unless there is, for example, humans in the picture. So the minute you have that, having a human interaction, basically what's the perception of privacy and security in the context of human is a very critical question. So having informatics is absolutely godsend. It's a wonderful situation to be in. All right. So it's a very, very unique situation for computer science here that we have these different departments with us. We are ranked, and as I said, we are severely sometimes underranked. At least that's what we choose to believe. Our students believe that. Our faculty believe that. But despite that, we are pretty reasonable in ranking if you think about it. We are ranked in U.S. News and World Report as 28th nationally. We've been there for a long time. Actually, ranking doesn't make us sense. We are clearly a top 20 school for sure. It's not even a question in the minds of most of the faculty and the students too. Okay? And if you look at the more recent rankings, which are not based just on reputation, but actually in performance and research productivity and so on, we are ranked much, much higher than that. So probably in the top 15, top 12, probably not MIT, Berkeley and so on, but the next year school. Okay? So we like to choose, we like to think that we sort of are probably ahead of UCLA, at par with UCSD. UCSD has come up significantly in the California schools, for example. We'd like to think we are sort of in the same category as Michigan and so on, okay? Texas, Austin, and so on. All right, so you're in good, you'll be, if you believe what you believe, then you're in a really good place. All right. So what do we have for graduate studies? Well, as you'd expect, like we are a pretty big department, around 45 faculty or so. So we cover pretty much all the areas that you can think of. We have both masters, which is sort of a new thing for us, and it's only been for a few years. And we have PhD program in all areas that you can think of: AI, architecture, embedded computing, graphics and visualization, computational neuroscience is a new thing that's sort of a lot of interest to be generated. Networking, cryptography, security, data management, informatics, and biology and medicine. You'll get to hear a little bit of that today as well. Parallel distributed systems, scientific computing, system software, theory. Basically, you can think of, probably this list is not complete, there are more things we are doing, but this is the list was given to me. All right. So there's some stats about the number of students. This stats is old, and you can tell that the slides were made in 2013-14, but we have not updated this. It's roughly the same. We have about 1,000 plus undergrad students. Which has been an astronomical growth. We are never that much, but we are a pretty strong or big undergrad school at this stage as well. Our focus has always been grad students, and we have roughly about 165, at that time we had 165 PhD students and about 163 master's students. Probably the numbers have changed a little bit, and there are slightly more masters than PhDs at this stage, I would think. Feel free to ask questions if you have anything at all, okay? The whole purpose of today's day is to make sure that you guys make the right decision of coming to UCI. All right. So our faculty are decorated like any faculty would be decorated. You go to any school and go and listen to this, you'll find out, hey, faculty have lots of accolades and so on. Some of those are interesting and important. Like, for example, NAE membership is a very prestigious thing. Okay. We have that. We have got lots of people who are fellows of, actually the numbers are probably old now, so we have lots of people who have ACM fellows, IEEE fellows and all that stuff. We have chancellor's fellows, we have Brent professors. These are special professors who were positions that were created to basically advance UCI and make it more competitive and so on. So there are a lot of such positions as well. I think the most interesting of all these things is the last item, because it reflects on students more than it reflects on faculty. So we have, if you think of, go into any area, architecture, databases, machine learning, whatever it is, and if you look at the top tier conferences, so I am a database guy, so I can tell you about database conferences, for example. If you look at Sigmod, VLDB, these are our main conferences, and just look around and just get a feel of what awards have been given to recognition to papers coming out of different schools. And you'll clearly find that in UCI, Sigmod Test of Time Award, which is the very major deal, big deal, okay, and best paper awards and multiple best paper awards, multiple test of time awards. UCI faculty have that, okay, and we are not exclusive, by the way. We are not even the strongest group of UCI. We don't even consider database to be the strongest group in UCI. Machine learning is at least as good, if not better, okay. So basically what I'm saying is that across the board, if you look at the major conferences, and you should do that, go and look at that. You'll find that a lot of students have got test of time awards, a lot of faculty and students from here have papers which have been extremely highly regarded and so on. And there's a reason for it, so obviously. So there is a sort of excellence in the research productivity and research that people do here. So I would encourage you to very heavily to look at that particular thing. The reason I'm emphasizing this repeatedly is because this is where you can see the quality of student research, okay, as well. All right. We wish we could have more funds, because we'd like to fund you even better, but we do have substantial funding, okay, which the faculty are able to attract. As of, I guess, 2013, our budget, I guess, was $34 million, and this is sort of the spread and so on, okay? Do I have a couple of minutes? How much time more do I have?
There's still time to.
Okay, all right, cool. So the question is, we have funding, which we keep getting and so on. For faculty, one of the things that faculty do is you do the research or and so on. We sort of think of the vision and the ideas, we write proposals which get funded, which then basically feeds you and continues to do research and so on, right? You pretty much understand now that you're in grad school, you understand the cycle, right? Vicious cycle as it might be. Okay, things may change with the elections coming up, but I don't know. But we don't know if there's a Department of Education or NSF and so on, which survives these elections, but assuming it does, things are looking okay, all right? Question that we have to ask is, okay, what are we doing? We get these fundings, what do we do? Okay, so what I'll give you is a very small glimpse of what we do, and maybe 5 minutes or so, and then you'll get a deeper dive slightly, not necessarily very deep dive, but a deeper dive with talk by Nalini. I think Pierre Baldi is going to talk. We also have a student talk.
Moshe, yeah.
Moshe is a student talk. You'll get a sense of, so things will get deeper and deeper. So Nalini's talk will be at one level, Pierre's will be about the same level, and then Moshe will be a very detailed talk of one particular thing, right? So you're giving you the breadth and the sort of a depth kind of a thing. All right, so what are we doing with these funds? That's the question that we are able to accumulate. If you think about it, there is a revolution going on in computing, as we all know at this stage. One of the finest things, to me, just completely amazing, is the cost of computing has become so cheap, okay, that you can put this silly computer in every device that you can think of. So everything has got, if you look at, let's say, a car, there are multitudes of machines which are kind of inside it, computational kind of whatever, networks that are running in it, right? A cell phone is obviously a computer. Look around, a projector is a computer. Everything is a computer at this stage, right? So there's huge amount of, this is the whole area called embedded, so I'm just calling it embedded everywhere. So we have got machines embedded about in every device that you can think of. And if I look back a little bit and reflect on this, when I joined UCI, which was about 18 years ago or so, we already had a center for embedded computing. Okay, or around that time there was a center for embedded computing. So we as a faculty have been thinking about this particular problem which is coming now. Like this is the thing that's becoming active now. For the last 20 years we've been working on it. We have basically amassed the world's leaders in the area of embedded computing and cyber physical systems. And they are kind of clunking away, thinking of what will happen basically. How do you make these machines work as a single whatever machine, so they can build applications on top of it, right? So there's a whole bunch of work going on in the embedded computing area. What do these machines do? They generate data, okay? And they generate data like nobody has generated data before. So you've heard this area of big data which is coming up. The big data of today is actually really small data in reality, because eventually if you think about it, Twitter or logs or clickstream data and so on, that's when a human touches a machine. Every human to machine interaction is sort of generating data, and we're calling that big data. When machines start talking to machines, which they are going to talk to each other, this big data of today is going to look like peanuts of tomorrow. The big data is actually about to come. It's not yet come. The question is, do we have the power to manage this data? And the answer is that, so there's this data tsunami coming from this embedded everywhere kind of stuff. And the ISG group, that is the group which I belong to and Nalini belongs to, we are sort of, this is the passion we kind of live every day. So what we're going to do about this particular data? There are lots of issues and challenges here. So one is, simple aspect is, okay, how do you manage this big data? How do you have the computational platforms to manage this? Well, that's just one aspect of the problem. The real challenges start coming in when you think of veracity, when you think of, let's say, the quality of the data itself, because data that's coming is not controlled. There is no single person sitting there curating the data very carefully. It's all dirty, it's all noise, okay? But hidden in that noise are gems of information that you do need, right? So this whole aspect of how do you go around kind of extracting those gems and making it kind of work in the context of applications. It's not just that, also. Data is very fast. So by the time you kind of scratch your head and figure out what the gem is, if the utility and usefulness of the data may disappear completely, right? So you have to sort of do it very, very fast. This needs a complete rethinking of how architectures of database systems, middleware, whatever you name it, application programs, whatever it is, including programming languages. You have to rethink programming languages as well in this context. So there's a whole set of things that have to be done around this aspect of big data and data tsunami. And ISG group, actually Harry, who is going to, I think you're going to meet him as well, he's looking at the same problem from a programming languages perspective and so on and so forth. So there's a whole bunch of activity around that area. All right. So we have data, hopefully you've cleaned it maybe, okay? What do we do with it? Well, we all know that. That's where machine learning, half the crowd here is kind of interested in, which is data analysis, like figuring out the patterns in the data, figuring out what's useful about the data, right? Machine learning. Machine learning, if you think about it, is an area which started around 40 years ago or so. And they had these wonderful models that they had developed, okay? Very advanced models. Problem they always faced was that nobody knew if these things work or not, because they never had data. Now that problem is solved, right? Data is coming there for sure. So that's not even an issue at this stage. The machine learning has a different problem at this stage. These machine learners developed these advanced models, whatever they were, but they always had very minute data sets in size in mind. In fact, there's a Irvine data set, which is the gold standard when people do any clustering, classification, modeling, probabilistic modeling, whatever they do. They use the UCI basically repository to test things. So we have a whole repository of small data. But that's not interesting anymore. What's interesting for machine learning is big data aspect of it, like doing it at scale, at large. Okay. And in fact, some of you guys are from Berkeley. Berkeley is a very wonderful work in that area. We are also very, very good in that area as well. So there's a huge focus. There's a whole center of data science that's come up. People are struggling to kind of figure out what to do in case of basically very large data sets and how do you take machine learning scale. Okay, so there's huge activity there. Analysis at scale. All right. 2 minutes? Okay. Yeah, that's fine. Okay. All right, so you have this whole aspect of data generation, data management, analysis, all that stuff happening. The question which I did not answer is what are the machines going to look like? So hidden underneath, and that's a typical computer scientist. A typical computer scientist is not a very flashy guy. He sits and does programming at the nuts and bolts level, right? So what's the architecture going to be? Well, this architecture itself is undergoing a revolution, as you know. Cloud computing is one of the, basically probably a de facto standard in which the whole computing environment is going to go towards. But connecting edge machines to cloud, what's the architecture going to look like? What's the architecture of the cloud going to look like? There's a whole set of work in that kind of a context as well. So I'll point you one example of a problem there. I put my data on the cloud. The question is the data secure or not? And there's a Freedom of Information Act, there is all kinds of Patriot Act, there's all kinds of stuff that happens, Snowden stuff happened. Think about that, right? There's a whole set of challenges of privacy and security in the context of data in the cloud itself. Cloud cannot be controlled. Is data sitting here? Is it sitting in China? Is it sitting in India? Is it sitting wherever it's sitting, right? Do we have jurisdiction or control in that kind of an area? So a whole set of challenges kind of come into play when you architect these systems, both from performance perspective as well as from a utility perspective and security and privacy perspective. And then there is a whole new evolution of the thing that drives the rest of the research for us. And you'll get to see with Pierre's talk today, as one example of it, is we're going to completely new applications, things which we never thought of as a domain in which computer science will be applied. So I think you'll get a very good sense of this in the context of biology today with Pierre. Okay, so there's a whole set of applications. And then there is a set of things like security and privacy. Oops, okay, then there are details like, all right. Security and privacy is obviously one of the main issues that came up. I kind of referred to it already. We have a very strong group in that as well. Okay, so what I've highlighted are some of the strengths of UCI, of our faculty, and the ongoing research projects. There are names that one can easily put to the box to faculty names, and if you are interested in any of these things, that you know, she'll basically try to organize and make sure that you get a little bit more deeper sense of what's going on. All right?
Okay.
Questions?
Any questions?
If not, welcome, and hopefully it'll be a productive good day for you guys.